So today we're going to cover Chapter 6, Section 6, last section of Chapter 6. And today we're going to talk about inequalities in two triangles. We're going to learn a theorem and its converse, and then we're just going to do some examples of it. So the theorem here is called the Hinge Theorem. Again, do not memorize the number. You can memorize the name or what it says. So it says, if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Now, I know this is a lot of words, but we're basically doing the same thing that we just did in 6.5. The only difference is we're comparing two triangles and their angle measures versus comparing two angles within the same triangle. So bottom line is the main thing you need to look for is that you have two pairs of congruent sides, and then you're going to look at the included angle measure. The bigger the angle measure, the larger the side across from it. So here, if they tell us that angle A here, the red one, is the larger angle, then that tells me the side across from that red angle, BC, is going to be the greater side. Now, a good example of this hinge theorem could be a door, or I'm going to show you with my scissors here how I can open and close the pair of scissors, and then the blades of the scissors will indicate the congruent sides. So the converse hinge theorem, and again, don't worry about the number, states if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. And again, a lot of words, but basically the same thing we did. We're going to look at that side length. We're going to look for the larger side, and that'll determine the larger angle. So if I were to add numbers to this picture, let's say I told you that the length of GH was 10, and then the length of KL was 8. You can see that 10 is bigger than 8, so that would make the angle across from that side that is a 10 would be the greater angle. And again, thing you need to look for is that you have two pairs of congruent sides. And then you're going to compare the included side to determine which included angle is larger or smaller. So for the first example, it says, given that D is the midpoint of AC, so again, when we have something that's a midpoint, I know that's going to split this into two congruent pieces. And then for my extra pair of congruent is the reflexive side here. So the two angles that they're asking me to compare, let me go ahead and outline them. So they're asking me, here's angle 2, and then it's comparing it to angle 1. And they're telling me up here in the description that angle 1 is the smaller angle. So this would tell me that the side across from angle 1 is going to be the smaller side. And then if 2 is the bigger angle, this would be the bigger side. So here this will tell me that BC is going to be less than AB. If you'd rather flip it around and say AB is greater than BC, you can do that as well. If it helps you to put in numbers, you can do that as well. Just figure out a number for 1 that is less than angle 2. And again, this is a straight line. So I could fill in here and say angle 1 is 60, and then angle 2 is 120. And then it's obvious to see that the bigger side is going to be across from the larger angle. You could have put in any number you want as long as angle 1 is a smaller angle than angle 2, because that was what was given up here in the problem. Example 2, we're going to use the converse of the hinge theorem. And I picked just random numbers for 1 and 2. I realized it was a straight line, so I had to make sure that my two numbers added to be 180. But then I just picked a number that satisfied what was given, and angle 1 had to be a smaller angle than angle 2. Let's try example 2, and we're going to apply the converse of the Hinge theorem. And again, they want us to just fill in that blank there and compare angle 1 and 2. Is it going to be less than, greater than, or equal to? So again, I need to look at the sides across from the angles. So again, I need to double check that I do have two pairs of congruent sides. And over here, this side is congruent to this. And then I also have the reflexive. So the two angles, again, that I'm comparing are angle 1 here. And he's going to look straight across at the 4. And then I'm going to also compare it to angle 2. And he's going to look at the 3. So because 4 is greater than 3, I can see that angle 1 is the larger angle here. So it's opposite the side with the side length of 4, and angle 2 is opposite the side with 3. So that tells me angle 1 is larger than angle 2. Okay, the next one, they want us to find the range of values for K. So I'm going to be setting up two inequalities to solve. I first, though, have to determine which angle is larger. So the first thing I'm going to look for is to make sure that I can use my Hinge theorem, and I need to determine if I've got congruent sides. So I have this side congruent here, and then I've got the one here in the middle, the reflexive. So the two angles I'm comparing are this angle right here, which is identified as the 5K minus 12, and then the other angle is right here. It's going to be the 38 degrees. So the 38 degrees is going to look across, and it's going to be across from side length, that is 19. And then the 5K minus 12, he looks across to the 18. So this tells me that the 38 is the larger angle here. So when I go to set up my inequality to solve, I'm going to be setting up 5K minus 12 must be less than 38. Let me do this in another color so it shows up a little bit better. So 5K minus 12 must be less than 38. Now this is going to be on the larger end. Now also realize that I also have to take into consideration on the bottom end. So I'm also going to set up another inequality to solve, and I'm going to set up 5K has to be minus 12 must be greater than 0. So K is going to have to be a number in between that's greater than 0 but less than 38. And I'm going to solve both of these. So if I solve the first one, I'm going to add 12. 5K is less than 50. Divide by 5. And K has to be a number that's less than 10. And then I'm going to solve the green one by adding 12. 5K has to be greater than 12. Divide by 5. And K is going to be a number that is greater than 12 over 5. So let me come down here. So the range of values, K is going to be greater than 12 over 5, but less than 10. And I can even make 12 over 5 2 2/5. So again, if you think about it, the measurement for that angle, K, not necessarily K, but the angle measure is going to be something that's in between 1 and 38. So let me write it like this. So the angle has to be something that's less than 38 but greater than 0. So this is why I had to write two separate inequalities, because technically this angle measure could be 0.1 or it could be as big as 37.9, and then it'll still be less than the 38. So if you think about plugging in one of the numbers that satisfies this inequality into 5k minus 12, let's say I pick a number, I'm just going to pick the next integer that's greater than 2 2/5. I'm going to plug in a 3. I'm going to plug in k equals 3. And I could get 15 minus 12. So that angle could be a 3-degree angle. But if I picked a number closer to 10 and plug in 9, say, I would get 45 minus 12, and that angle could be a 33-degree angle. So these are all acceptable angle measures that are going to be still, that's greater than 1 degree, because the smallest it would be is like, you know, I'm not going to give you like a 0.5 degree angle, but something in between 0 degrees and 38. The answer is right here. You could either represent it as a mixed number or an improper fraction. Everything that's outside of that purple box is my explanation of how I picked acceptable values of k to show you what could be an acceptable angle measure for that. And again, remember 38 in this picture had to be the larger angle. It can't go over 38 degrees for the other angle that's represented as the 5k minus 12.